In this section, we're going to be looking at rational and irrational numbers. A rational number is a number which can be expressed as a fraction. The clue is the word ratio within rational. We know that there is a relationship between ratios and fractions, so a rational number is a number which can be expressed as a fraction. Let's just explain what we mean by writing a number as a fraction. We mean writing it in the form a over b, where both a and b are whole numbers. We can do this with decimals which truncate, decimals which stop. For example, 0.2 is the same as 1/5. 0.5 is 1/2. 0.24 is 24 over 100, which we can cancel to 12 over 50, or to 6 over 25. So all of these truncating decimals can be expressed as a fraction, with both numerator and denominator as whole numbers. We also have no problem with recurring decimals. 0.3 recurring, we should know, is 1/3. If we have 0.21 recurring, this can be written as 21 over 99, which cancels to 7 over 33. So if we have decimals which truncate, i.e. stop somewhere, or which recur, they can be expressed as fractions, and therefore all truncating or recurring decimals are rational numbers. If a rational number can be expressed as a fraction, it follows that an irrational number is a number which cannot be expressed as a fraction. So irrational numbers cannot be written in the form a over b, with a and b both whole numbers. Typical numbers like this are pi, the square root of 2, or the cube root of 5. They have infinite decimal expansions. Decimal expansions which go on forever. However, this is also the case with a recurring decimal. So the second part of this is that the decimal expansion has no recurrence pattern. Even before viewing this video, you must have heard that this was the case for pi. You'll have heard stories of people remembering the decimal expansion of pi to thousands of decimal places. Clearly, this wouldn't be a very impressive feat if it recurred. Pi has an infinite decimal expansion with no recurrence, so pi is an irrational number.